Hello everyone, my name is Arya Devdhar and this is part 6 of NCERT Class 10 Science, Chapter 9, Light, Reflection and Refraction. Okay, so in the last part we covered spherical lenses. We saw the image formation by both convex and concave lens. So in this part we are going to see sign convention for lenses, right? So we are going to start with sign convention for lenses, spherical lenses, right? After that we are going to see the lens formula, then magnification in lenses, obviously, magnification, and then lastly we are going to see power of a lens. So this part is very important regarding the numerical section of this chapter. Okay, so anyways, let's begin with sign convention. Okay, so the sign convention for lenses is very similar. You might even say same as the mirrors. Okay. The only difference is that in mirrors, all the distances they were measured from the pole, right? But here in lenses, they will be measured from the optical center. That is the only difference. But still, I will revise all of the rules here once again. Okay, so the first rule is that the object is always kept on the left hand side of the lens. Okay, always on the left hand side. So that always means that U is negative. U is, you remember, I hope you remember what U is. U is the object distance. So here, the distance of the object from the optical center of the lens. That is U. I'm sorry, I wrote nu. It's not nu, it's U. Okay, now, again, this is the positive x-axis. This is the negative x-axis. All distances measured to the right hand side of the optical center are positive. To the left hand side of the optical center are negative. All distances above the principal axis are positive. All distances below the principal axis are negative. Okay. So that means that V can be positive or negative. So here I'll distinguish between both convex and concave lens. Okay, for you. So convex lens, first of all. For convex lens, F is positive. Okay, now there is a bit of confusion for focal length of both convex and concave lens, right? For mirrors, it was very easy, but here the confusion is that there are two foci, right? There are two foci on both the sides. So then which foci should we, consider for the focal length, to measure the focal length? If you consider this foci, F1, then it will be negative. If you consider F2, it will be positive. So then which one to consider, right? So here, how you'll understand? For convex lens, if the rays are thrown parallel to the lens, right, they converge at this focus, right, at F2. They converge at F2. And F2 is on the right side. So the focal length is positive. So F2 is considered for the focal length. For convex lens. For concave lens, I'll draw a rough diagram. For concave lens, like this, right? This is O, this is F2, this is F1. If they are thrown parallel, they appear to diverge from F1. They appear to diverge from F1, don't they? Right? So here F1 is considered for focal length and F1 is on the left side. So hence concave lens focal length is negative. Understood? Okay. So for convex lens focal length is positive. Okay. Now again ahead, U is negative. Object distance is negative. Image distance, it can be positive, it can be negative. Image distance can be positive. Usually it is positive, but for virtual image it is negative. So or negative. Understood? Right? HO, height of object, always positive. Height of image, negative or positive. Right? Negative or positive. Understood? Convex lens. Now moving on to concave lens. We'll see the same thing for concave lens. Focal length is negative, as I showed you up here. right? U is also negative. V is also always negative here because the image formed is always virtual and erect. It was always formed on the left hand side here. So it is negative. V is also always negative, right? Height of object is always positive. Height of image is always positive because it is a virtual and erect image. Okay. So for concave lens, it is fixed. For convex lens, it may vary. Some two of V and HI may vary for convex lens. Okay, understood the sign convention? Okay, now let us move on to lens formula. So now if you remember the mirror formula was 1 by f is equal to 1 by v plus 1 by u, right? This was the mirror formula. The lens formula is quite similar, okay? But here the lens formula is 1 by f is equal to 1 by v minus 1 by u. So don't get confused. Don't get confused. Remember mirror and just remember that lens has a minus sign in it. That's all. Okay. So I'm just going to rub the lens mirror one here. It will only cause confusion. Right. So f here is the focal length along with its sign. Along with the sign. V is the image distance. Image distance. U is object distance. Again, the derivation for this is not in your 10th standard. It may be in your 11th, 12th standards, right? So this is the lens formula. So this lens formula is general and it is valid and applicable in all situations for any spherical lens. Any spherical lens, but it is sign sensitive. I'm sorry. Yeah, so it is sign sensitive, which means that you have to be careful. You have to understand the signs when you put it in. So if focal length is negative, it will be minus 1 by f. If, for example, image distance is positive or image distance is negative, it will be minus 1 by v. Okay, yeah, it is sign sensitive. Understood? This is the lens formula. Simple enough. Related to the mirror formula, and you will remember it. Mirror formula is 1 by v plus 1 by u is equal to 1 by f. Lens formula is 1 by v minus 1 by u is equal to 1 by f. Understood? Okay. Moving on. Now magnification. The definition for magnification is same as the definition for magnification for mirrors. Same for lens. Okay, no difference. So it is defined as the ratio of the height of the image and the height of the object. Ratio of height of image and object. Okay. So if HI is height of image, HO is height of object, then M magnification, it is HI upon HO. It is also related to object distance and image distance, so V and U. But here V and U formula is different. Okay, so this is one formula. Now if you remember, for magnification in mirrors, M was equal to minus V by U. Minus V by U. Here in lens, M is equal to V by U. There is no minus sign. Okay, again, it is exactly opposite. It is exactly opposite as it was in your mirrors, right? Exactly opposite. Understood? So these are the two formulas for magnification. The first one is M is equal to height of image upon height of object, and second one is M is equal to image distance upon object distance. Okay, simple. Okay. Okay, now we'll move on to the last part, which is power of a lens. Now, what exactly is power of a lens? So I'll write down the definition. Maybe you'll understand from it because it's a very simple definition. Power of a lens. Ability of a lens to converge or diverge light rays right? Which depends on its focal length, but that is not required in the definition. Okay, so ability of a lens to converge or diverge light rays is power of a lens. Okay, that is basically power. So it can also be like represented the degree of convergence or divergence of light rays achieved by a lens is expressed as power. I'll write this one down as well, because the define power of a lens is a very common question in your boards for 1 or 2 marks. Okay, so degree of convergence or divergence of light rays achieved by a lens, by a lens is power, is the power of that lens. Okay, so these are the two definitions. So basically, it is the ability of a lens to converge or diverge. So for convex lens, it is to converge light rays. How much can it converge? How many light rays can it converge at a time? That is the power of a lens. Very simple. Okay. So power of a lens, it is denoted by P. Okay, denoted by capital P. And there is a formula, obviously, for power of a lens. The formula is P is equal to 1 divided by F. 1 by F. And F, there is a condition. F should always be in meter. Never in centimeter, never in millimeter, only in meter. So if it is given in centimeter, you have to first convert to meter and then you have to use the formula. Otherwise, your answer will go wrong. Okay? So P is equal to 1 by the focal length. So power is basically the reciprocal of the focal length. Understood? Now the SI unit of power. SI unit of power is diopter. So this is a new unit, diopter, D, represented by capital D. Okay, so if F is in meters, then power is expressed in diopters. So that is the relation. If F is in meters, then power is in diopters. Okay, if F is in centimeters, then power unit is not diopter. Okay, so now I'll define one diopter. Okay, what is one diopter? Again, a very common question. Define one diopter power of a lens. What is one diopter? One diopter is the power of a lens. It is the power of a lens whose focal length is 1 meter. Very obvious, right? It is the power of a lens whose focal length is 1 meter, because here we'll get T is equal to 1 by 1, which is 1 diopter. So 1 diopter. Understood? Okay. You may note here, okay, one more thing, that power of a convex lens power is always positive. Concave lens power is always negative. Obviously, right? Because convex lens focal length is positive. For convex lens, focal length is positive. For concave lens, focal length is negative. And power is the reciprocal of focal length, right? So, for convex lens, power and focal length are positive. For concave lens, power and focal length are negative. Understood? Okay. So, basically, that means, for example, if someone says, or suppose the lens prescribed to a person, right, glasses, right, if the power is -1 diopter, that means that the lens prescribed is a concave lens. If it is plus 3.5 diopter, that means it is a convex lens. Okay, simple enough to understand, right? So remember the formula. So in this part we covered lens formula, the sign convention of lens, obviously, lens formula, then we saw magnification, two formulas for magnification, m is equal to hi by h naught and is equal to v by u, right? And we saw the power of a lens in detail. Okay, the definition of one diopter, SI unit, the formula, and for convex and concave lenses, whatever it is. Okay, so that's all for this part. I'll see you in the next part. Thank you.